Today we're going to run a hypothesis test on the question of, were these students older on average than 11 years old when they received their first cell phone? And we're going to use a significance level of 5%. So whenever you're testing a question, first you go to your Excel sheet and you take a look at your data and you compute, in this case, the average and the sample standard deviation. In this case, we see that in our sample, students were 12.08 years old on average when they received their first cell phone, with a standard deviation of 1.876 years. And our sample size was 37 students. And so the question is this sample statistically significant enough for us to be convinced that these students were older than 11 years old on average when they received their first cell phone? So we go to SALT. And once we get to SALT, we click on Inferential Statistics and One Sample T-Test. We just saw that our sample mean was 12.08 years with a sample standard deviation of 1.876 years and a sample size of 37. Our hypothesized mean was 11 years old, and we want to know if these students were older than that or greater than that in years when they received their first cell phone. We generate our results, and we see that our p-value is 0.000626, which means it's incredibly unlikely that the real average is 11 years old, and our sample is just really big. In fact, the p-value is so small, it's smaller than our level of significance, and we're convinced that it's true. These students are older on average than 11 years old when they received their first cell phone.